Hey everybody, got a new hey, got some new backgrounds for you by the way while we work. Um yeah, so we got our last part of circles that I'm going to go over today, and then after that, what is it? After circles, we're going to jump into 3D geometry by the end of this week, and then we'll be done. Cool. All right. So, let's get to it. So we're going to talk about three concepts today. The very first one is going to be secant tangent theorem. And what secant tangent theorem is AC times BC. This is going to make zero sense, but I promise you, of course, that it'll make sense in a second, will equal DC. So secant tangent theorem, AC times BC equals, oops, I messed it up. Oh, no. Oh, all right, let's try this again. Secant tangent, I am all over the place. It's not, no, there. Theorem. And it is AC times BC equals DC squared. There we go. All right, that's correct. AC times BC equals DC squared. So what in the world are they talking about? Well, they are talking if we have a circle, right? And then give me my lines. A secant, you guys know what a tangent line is. We've talked about that. A tangent line is a line that comes along the circle, touches it at exactly one spot, right? Touches it only in one spot. And then, you know, continues onward for a long time or infinitely, theoretically, right? A secant, so a chord is a line that goes from one end of the circle to the other, right? But a secant is a line that goes through the circle and keeps going, essentially. Like, you know, protrudes from the other ends. It keeps going. So this is a secant line. And then we know this one as a tangent line, right? So the nice thing about these questions, though, is they always look like this. They always look just like this, where you have a line going through the circle, meeting up at a point, and then going down towards something. And there are four points that matter. There is right here. Oh, that needs to be a lot bigger. So there's this point right here. That is really big. Yeah, whatever. Right? So there's that point right there. There's the point right here. So the 2 points where the secant crosses the circle's edge, the point where the secant and the tangent line meet up, and then the point of tangency where the tangent line and the circle touch. These are the four really important points. I'm going to label them, and then things might start making sense. This guy is A. This one is B. She is C. And homeboy over here is D. So secant tangent theorem is just saying that when a secant, a line that's going through a circle, all the way end to end, you know, skewered it, passed right through it, meets up with a tangent line, you can use this formula to solve missing pieces. Now, this formula is very specific, very, very, very specific. Oh, that's really tiny too. So AC, this whole distance, times BC, this itty bitty little distance right here, this guy right here, will equal DC, this distance right here, squared. Now, this part is really, really important. The A to C part. This part, I'm just drawing now. I'm just having fun. All right. A to C is really, really important. Because if you notice, this part right here, AC, happens to also contain BC. AC is this entire line from this outer edge all the way to where it meets the tangent line. This is really important because it's how they use this, the most confusing part of secant tangent theorem. So of course they're going to do the most questions based on it, because that's, well, that's how it is, right? So we've got our notes right here. What I'm going to do is pull up a practice question, and we're going to do it. So sometimes you'll see the secant and the tangent create like what looks like an angle out here. They do this specifically on purpose to confuse you when it comes to like the circumscribed angles that we were looking at, which is made by two tangent lines. They're going to do this on purpose. They're going to make it look like this. And I mean, it's underhanded, but I don't know if you've noticed, but that's a lot of your tests. So aside from that, what it can look like is this right here. The secant goes all the way through the line. The tangent line comes all the way down here. We can solve this. We'll solve this right now, actually. Why isn't... There we go. So all of our letters are the same. And I'm saying that because the letters don't have to be the same. So even though the theorem is AC times BC equals DC squared, well, they can change the letters entirely up. And they're going to do that. I think the worst one I've ever seen is they actually used A, B, C, and D, but they changed the order entirely. Like they put A here, B here, C there, D there. Like they just to mess with you. So make sure you're paying attention and you understand what this means, which is the whole secant line times the small part equals the tangent line squared. So whole secant times small part equals tangent line squared. But this one, we don't have to worry too much about the letters. I mean, of course, I'm fairly certain I mixed up the letters on the other. I didn't mix up the letters on that one. Man, that's not good. I should mix up the letters. Maybe I will. All right. You know what? I'm 100% going to mix up the letters. Oh, it's going to take too much time. All right. We'll work with it. Just make sure, just make sure that you're paying very close attention to what letters they give you and where they are. I would suggest, personally, rewriting them. So like if you got different letters, I would just ignore those letters and put A, B, C, D. Like go along the secant, A, B, C, and then go down the tangent, D. I would just label it the same way every time for me. And then remember the AC times BC equals DC squared. But however you do it, it's up to you. All right, so let's look at how to do this. It's not hard. It's not difficult at all, other than them trying to trick you. Once the tricks are out of the way, once you've kind of gotten out of that, you literally just plug it in. AC times BC equals DC squared. Well, we don't know DC. They didn't tell us DC, but they gave us AC and they gave us BC. So we know 13 times BC is 4 will equal DC squared. Well, I mean, I have no delusions. I know I'm not the greatest at mental math, so 13 times 4, oh, that's 50, no, 62. But, all right, 13 times 4, 52. See, well, that's why you make sure you check your work, right? We get 52 equals DC squared. All right, well, what do we do now? How do we get rid of this squared? The answer isn't 52. DC isn't 52, right? Because we still have DC squared. Well, the opposite of squared is square root. You square root everything, and that cancels the squared out here, and you just get the square root of 52 equals DC. So Going back to our calculator, 52 square root. We get 7.21, and that's it, equals DC. That's your answer. So secant tangent theorem isn't super difficult in any way, shape, or form. There's just a lot of little tiny tricks that they can throw at you to try and mix everything up. You know, basically make you make a mistake. A lot of your geometry FSA that you're going to be doing in about 2 weeks is like that. A lot of it is trickery. So just got to make sure you're paying attention and you use your time, because you're given plenty of time. So I say use it all. Just use the whole school day to work on your test. And if you don't finish it in the whole school day, you can ask for even more time. But I know that's a lot of work. I know that a lot of you don't want to do that, but at least make sure you take your time. Because again, little tricks aren't fair, but they're going to do them to you. All right, so let's clear that, and do the second one that I wanted to go over. So I'm a little upset I didn't mix up the number or the letters, but this one's already kind of difficult. It's probably why I didn't mix up the letters. But so you've got A, B, C, D. Everything's in order, right? And then we can label this. AB is X. And I already have a problem with that, right? BC is this little part. That's 5. And then what in the world? They gave us DC. They said it's 12. That's weird, right? Why would they give us that? Probably because there's an X there. So we could just plug this all in. There's already an equal sign. We could solve for X. But there's one thing you really, really, really have to be careful of. AB is this section. It is this chord, this line from this side of the circle to this side. It is not AC, the distance from this all the way to the intersection, right? AC is all of this. But they only gave us this part, AB. We want AC. We want, oh, it's so tiny. Why are all of these so freaking small? Oh, whatever, there's nothing. Oh, there we go. Go into that. Okay, and let's go blue. So we want all of this. We want from A to C. We need that for the first part. So let's find it. We know that AB, this very first part, going from A to C, we run into A, then B first. They labeled that. They said that's X, right? And then if A to B is X, but we still have B to C to go, they gave us that too. Well, how would you figure out the distance from A to C? Well, you would add these up, right? X plus 5. That is my AC. So here, let me go here. So this is AC. X plus 5. Now we can keep following our formula here. Times BC. Well, they gave us BC, didn't they? Look at that. BC equals 5. So 5 equals, and then DC squared. Holy, they gave us that too. 12 squared. All right, this equation has become significantly easier to solve. Because now it's just some basic algebra, right? We got 5 on the outside being multiplied by X plus 5 equals 12 squared. Well, the very first thing you should do anytime you have this multiplication in this, you guys know this, you're going to distribute, right? I should probably fill in the rest of the equation. This is BC right there above the 5, and then this is BC right there. All right, so we're going to distribute, right? 5 times X, 5 times 5, 5X plus 25 equals, and then 12 times 12 is 144. And now, we're just doing algebra at this point, aren't we? 5X plus 25 equals 144. You guys know this, right? Gonna go ahead and minus 25 from both sides. That's fine. 5x will equal, not gonna lie, I'm not doing that in my head, I got enough work to do. 144 minus 25, thank you. 119. And then, of course, we divide. Oh, what's the symbol for divide? I always mess this up. Nope, that's pi. Dang it, I never remember the symbol for divide. I do these little, you can like punch in codes into your keyboard and it'll bring up certain symbols. And division is Alt 0247. There we go. I always forget that though. All right, so divide both sides by 5. And 119 divided by 5 is our answer. So x equals 23.8. So that's pretty much the hardest kind of question we're going to do, where you have to piece together the formula from what, like the pieces they give you, along with a variable. Now, there is 3 questions on your quiz on each of these topics. And of course, this is going to be the last one for secant tangent theorem because it's the hardest. It's got a variable and a bunch of algebra and stuff in it. So just make sure you're paying attention. You apply this formula right here, the AC times BC equals DC squared. You apply this correctly, pay attention to your letters, make sure they're in the right order, everything fits in with this, and you should be good to go. Again, I keep saying this, but I mean, nothing in the circles chapter is particularly difficult. There's just so much, and they start to look like each other after a while, and that's when you start confusing things. But, all right, so we got secant tangent theorem out of the way. Peace out. Now we're gonna do, crossing chords. All right, this one will be nice, quick, and easy. So we got our circle, make them kind of big. All right, we got our circle. And then we're going to have 2 chords. Remember, a chord is just a line that goes from one end of the circle to the other. If it goes through the center, then a chord is diameter. If it does anything else, it's just a chord. But let's just say we got these guys right here. And then we're going to take the measurement. Well, it's fine. So we got 2 chords crisscrossing. 2 chords making an X crisscrossing across a circle. Now, they create angles. Because anytime 2 lines crisscross, they create angles, right? Now, you know, and I'm going to say you know because I feel like you do know, that when you crisscross these lines, you create 2 pairs of vertical angles. As in, these 2 angles are equal, and these 2 angles are equal to each other, right? This guy and this guy, and then this guy and this guy. So vertical angles, right? So let's say he's X. We don't know him. We want to know him, right? We don't know that guy. Well, how do we solve that? It's a nice, simple thing. You have to know the arcs, the degrees, not the length, but the degrees. So let's say this guy is 62 degrees. And then the one over here, we're going to say is, I don't know, 48? Why not? So this is your typical kind of orcs crossing question, chords crossing question. We got solve for X, you know this arc and this arc. What do you do? Well, they almost look like central angles, which is confusing because that's not how you solve them. And of course, being as how this chapter is confusing and everything looks the same, That's what they're going to do. They're going to try and play you. They're going to try and make you think that, oh, well, this is equal to this, so they're equal, right? And I guarantee you, if this was a question on the test, the very first answer choice would be 62 degrees. Because you're like, oh, that's a central angle. They're equal. They're going to do that to you. So we're not going to fall for that. When two chords crisscross, there is a formula, a little quick formula for solving at the angles inside. Crossing chords, arc 1 plus arc 2 over 2. Let's do this and that. Now, when I say arc 1 and arc 2, I mean this angle's arc, right? Because an angle makes its own arc. And I also mean the one that it is vertical to. Its vertical angle arc is arc 2. So arc 1, arc 2. You're going to take those two numbers, add them up, divide them by 2, and that's your answer. That's it. Easy peasy lemon squeezy, right? 62 plus 48 over 2. And whatever that equals is your answer. We get 62, that's 110, right? Yeah, 100 and then 10, so 110 divided by 2 is, I should know this, 55. Oh, and it's degrees. There you go. Add up the arcs, divide by 2, and you are done. So the hardest possible way I could see this question being asked, do I have it here? Okay, that's one way of doing it. Okay. So there's a lot of things they can try and do to confuse you here. One thing that I have seen is I have seen them give you all the measurements. Right, let's do actually all I have to do is 62. Let's say this is 178. Why not? And then this is 50. So let's say they gave you something along these lines. They said, all right, solve for x. Well, you're missing the other arc. You don't have your other arc to add up to. You could solve these two, right? And then you could use them to solve this guy, absolutely. But let's stick to our equation. How do we find our missing arc? Well, you should know, and I know, you know that every circle is 360 degrees, right? 180 is half a circle, 360 is a whole circle. Well, all of these degrees would have to add up to 360. So we have 3 out of 4. So if we add these up and subtract them from 360, this is what's left over. So 50 plus 62 plus 178 is 290. 360 minus 290 is 70. So this guy would be 70 degrees. And then we would use him to solve for our angle here by adding 70 and 62. 70 plus 62 equals, and then we divide that by 2, and our angle is 66. So that's probably the hardest kind of question you'll see when it comes to this particular thing, when it comes to crossing chords, is they'll just, you know, seemingly omit information. Like they won't give you this information, but you can still use everything to solve it. Let's look at the practice question that I created for this, because it's a little confusing. Because again, there's all kinds of ways they can flip it up, and this is one of them. But we're going to do exactly what we're supposed to do. You add up the two arcs on the outside, right? divide by 2, and that's going to equal our inside angle. Even though we have it, I'm still going to write out the formula because it's going to help me. X plus 78 over 2 is going to equal 22, right? There we go. It's going to be gigantic, isn't it? Yeah, it is. All right, whatever. All right. So what do? Well, we got to get rid of this -2. We're just doing algebra at this point, right? If it was addition, you would subtract. But this time, uh-oh, I goofed. I just realized we're going to get a number that doesn't make sense. Ah, dang it. Whatever. We'll solve this question, then I'll tell you how I screwed up. All right. So you got you got division here, so you want to multiply both sides by 2. Where'd they go? Right? These cancel out, of course. These go away. And you're just left with x plus 78 equals 44. 2 times 22. And if you're paying attention and following along, you realize how I messed up when I made this question, because you minus 78 from both sides, because that's the opposite of addition, right? And you're left with x equals negative. What is that going to be? 34? I think it's 34. I don't want to mess that up, though. It's 34. Why am I second guessing myself? You know, you make one mistake and then you just start guessing or second guessing everything you do. Yeah. All right. So x would be negative 34. That's, of course, impossible because we don't measure things in geometry by negatives. Something can't be negative feet, you know, negative miles. So this couldn't be negative 34, which means I messed up the question because that's not possible. But regardless, that is how you would solve if one of the arcs was x instead of the angle on the inside. Is you would set it up normally in the equation and then just solve it algebraically. All right, last bit of info. Oof, and this one's the doozy. So now we need to talk about the equation of a circle. Now, you know the equation of a line, right? Equation of a line is y equals mx plus b, right? That's the equation of a line. Well, circles have the same thing. Circles have an equation, and it's complicated and ugly. It is x minus h squared plus y minus k squared equals r squared. So what in the world is all that, right? Well, let me help you out. Just like in the equation of a line, m is the slope, it represents something. B, right, that's the y-intercept where this line crosses the y-axis. And then x and y is any point on this line. For the circle, h and k are the center of the circle, like so. It's the actual coordinates of the center. So they're just straight up saying, like, hey, right here and here is the coordinates. Problem is that you see this minus, that messes up a lot of people. If this was x minus 2, y plus 1, then your equation, your center of the circle, you need to flip the signs on these. So if this was minus 2, then it would be 2, and if it was plus 1, it would be negative 1. You have to flip the sign when you're getting the coordinates for the center. It's just going to mess a lot of people up. And then you know what r is, right? Radius is r, but in this case, it's squared. And I'll show why that's a problem. And that's it. Equation of a circle is pretty simple. It's got this crazy looking format, but all you need to do is look at, okay, H, K, R, right? Oh, well, I just realized that there's a, So, what can we do with equation of a circle? Well, one of the very first things you'll see very often is like question number 1. What is the center of this circle? And then you will get an equation, right? X plus 2 squared plus y minus 4 squared equals 16, right? So you'll get like, what is the center of this circle? Well, you come over here to H and K, right? Our center. You just pull them out and flip their signs. So the center is at, flip the sign, positive 2 becomes negative 2, negative 4 becomes positive 4. There's your center. And then you'll also get 2, not 22, 2. What is the radius of this circle? Based on the same equation, right? Well, you got to pay attention because in the equation, it's r squared. When you see a circle's equation, they have already squared the radius. They've already taken the radius and multiplied it by itself. So you need to, oh man, that's whatever, I was wrong. You need to take the radius they give you, right? They take the r squared, and you need to take it back a notch, and you need to square root it. And that would be your radius. So that's how they're going to use equation of a circle most of the time. They can complicate it in all kinds of different ways, but of course, the 2 most important things you need to know is H and K are the center, and the radius has already been squared. So when you see a radius of like 2, you're like, oh, that doesn't have a perfect square. The radius is 2. No. The radius is a decimal, and you need to square root whatever number you see there. Whatever number you see here at the end of the equation needs to be square rooted in order for you to find the radius. All right, so let me leave these guys up. Oh, that guy, right? And then, sling a question at you real quick. What if you saw this? Equals 25. Right? You're not looking at an H and K, right? They don't seem to be there. Well, math has something that represents nothing, doesn't it? If we don't see H and K, it's because they're nothing. They are 0. Your center for this question would be 0, 0, or the origin. If the x and y are not being minus or if they're not being subtracted from or added to a number, then you're on the origin. Your center is 0, 0, because you don't see it here. It's minus 0, so nothing. And then your radius for this question would be the square root of 25, right? So square root of 25, which equals 5. All right. So, of course, what I'm going to do is go right into the hardest kind of question you're going to see on equation of a circle. So let's say we were given this. And this looks horrifying, right? Graphs, circles, points. Oh no. Well, they're going to ask us, what is the radius of this circle? What is the radius of this circle if the center is on the origin? Right? Or just, they probably would just ask us, what's the equation of this circle? So let's figure that out. I don't have anywhere to write. Let me go. New notepad. There we go. All right. Well, let's write our equation as we have it thus far. Right? They said that the center is the origin, or I'll write the question out. What is the equation of the circle to the left? Right? That's what we're trying to do. Figure out the whole equation. Well, we can write what we know so far. We know that the center is at 0, right? Center is at 0. They said, well, they didn't say so. I said so, but the center is at 0. So x squared plus y squared equals, but now we have a problem. We don't know, I have all kinds of buttons. We don't know r. We don't know our radius. There are two ways we can solve this. They gave us a point on the circle, negative 15, 8. There are two ways to do this. One, you could very easily, since you know the origin, right, and you know this point right here, if you know the center and an outer edge, you can use the distance formula to find the radius. Because this line is the same no matter where you go around the edge. Always going to be the same distance, right? That's the radius. So we could do that. And you know what? I'll do this one at a time. So let's use distance formula for this method. And then there's an algebra formula for the other method. We'll do this one first. So if you do not remember, distance formula is square root of, and you need to remember, but we will talk about that later. This formula is x1 minus x2 squared plus y1 minus y2, squared, and that's it. That's it. Cool. Well, I'm going to label these guys out, right? I have 2 points. I have 0, 0, and then I have negative 15, 8. That's the point they gave me. Well, I'm just going to plug them in. This is my x1, x2, y1, y2. I'm going to just go like that, plug it in, and solve this out. Distance formula looks intimidating. Even by today, like even after everything we've done, I know distance formula is still like, oh God, it's distance formula. But it's really not hard. 0, and then it's minus a negative 15. I'm doing that on purpose because when you minus by a negative, right, you change stuff. So I'm just writing it out right now. And then 0, right, my y1 minus 8. So when you minus by a negative, you add. So we end up with square root of 15 squared plus, well, it'd be minus, right? We'll do it this way so we don't get confused. Plus negative 8 squared. I mean, this doesn't matter though because we're about to square it, right? And any number times itself is going to be positive. So, all right. Square root of, my square roots just, I think my square roots get bigger and bigger and bigger as every time I draw one. Okay, calculator. We'll do 15 squared is 225, right? Where's my text? There we go. 225, ooh. 225 plus 8 times 8 is 64. Yep, there. So plus 64, 289. And then our last step is to square root that, right? 289 square rooted is 17. So 17 equals our radius. That is one way of solving this. If you're comfortable with the distance formula, you can, plug in 2 points and work it out, then perfect. All right, go ahead and do that. It's going to work. Any point on a circle, right? Any point on a circle can be used to find its radius if you know the center. If you know the center and any point, then you can find the radius using the distance formula. Well, let's look at the algebra method. Just like in a line, right, y equals mx plus b, y and x are just any point on the line. Well, y and x here are any point on the circle. And we were given a point on the circle, negative 15 and 8. So we can take our exact equation that we have right here and just plug in our numbers that we have. We were given, for x, negative 15. Ooh, that's not it. That's it. Plus our y, we were given 8. And that's going to equal r squared, right? No, squared. Oh, man, I'm all over the place. These are not squareds. These are... There we go. I'm having a day. There we go. R squared. So we just plug in our x and our y and then solve for r. And we're going to come out with something, well, incredibly similar, aren't we? We've got 225 plus 64 equals r squared. Dang it. Or 289 equals r squared. There it is. And then how do you get rid of a number that's squared, or how do you get squared off a variable? Well, you square root. You see in the similarity here between what we did in the algebra formula and exactly what we did in the distance formula, which is the square root of 15 squared plus 8 squared, square root of 225 plus 64, square root of 289, square root of 289, right? 17 equals r. So either of these methods work. If you notice the algebra and you notice the end of the distance formula, they're exactly the same thing. Literally, right? Square root of 289, square root of 289. They're the same thing. But don't mess up the final part. They said, what is the equation of the circle? So you need to write out the equation of the circle, right? X squared plus y squared equals, remember, it's r squared. It's not 17. If you put 17 here, you're wrong. It's 17 times 17, which is 289. This is the equation of the circle. This would be your answer. Don't do all of that work. Don't do all of the work and then get it wrong because you put the actual radius here and you didn't do the radius squared. Don't do that. Make sure you get that right. All right. So those are the 3 concepts for this, either the final circle concepts that we have to go over. So we've done, I think, 9 different concepts now in circles. And I know they've been rapid fire and really quick, and I'm sorry, but we started like a month late, and so we would have been doing this a month ago in a normal year, and then that we would have had like well, 3-4 weeks to practice for the exam, not a week. But alas, here we are. So we'll get it done. We'll do our best. You know, I've done my best, you've done your best, and we'll move on from here and get into summer vacation and enjoy it. But until then, y'all, have a great one, and I will talk to you later.